Just 20 years ago, almost every car on the road still burned gasoline, and electric vehicles were dismissed as a century-old failure. Today, new electric vehicles outsell internal combustion cars in entire countries, and automakers are racing to survive a shift few thought possible. How did one technology lose for 100 years, then suddenly win? Within a single generation, everything changed. The world of gasoline cars was anything but quiet. City streets rattled with the clatter of engines, gears grinding and exhaust coughing into the air. A haze of smoke hung above intersections, mixing with the sharp tang of burning oil. In the early mornings, mechanics leaned under hoods, hands blackened by grease, coaxing stubborn engines to life with a crank and a prayer. For every trip, there was a ritual: checking spark plugs, topping off fluids, hoping the next turn of the key would not mean a busted knuckle or a dead battery. Gasoline was not just a fuel, it was a lifeline. Drivers watched the needle on the gauge, always planning the next stop at a gas station. In winter, thick oil turned engines sluggish. In summer, the heat amplified every odor, from leaking fuel to overheated radiators. The noise was constant, pistons firing, horns blaring, the low drone of traffic blending into a metallic roar. Even the simple act of starting a car could be a gamble. Before electric starters, a moment's slip on the crank could mean a broken arm. Streets filled with the sound of failed attempts, each backfire echoing off brick buildings. Underneath it all, the city pulsed with the rhythm of combustion, powerful, relentless, and dirty. Yet for all its dominance, this was a world built on compromise. Drivers accepted the grime, the fumes, and the upkeep as the price of progress. Few stopped to imagine that somewhere, a quieter, cleaner way to travel had already existed, and for a brief moment had even seemed poised to win. Electric cars did not vanish overnight. They were squeezed out by a series of blows that left little room to breathe. The first hit came from inside the battery box. Lead-acid batteries, heavy and stubborn, set a hard ceiling on range and speed. Even the best electrics of the 19-teens struggled to cover more than 50 miles on a charge, and cold weather could cut that in half. For city errands, this was enough. For dreams of open roads, it was not. Then came the price war. Ford's Model T rolled off assembly lines by the thousands, its price dropping from $850 in 1908 to less than $300 by the early 1920s. Electric cars, still assembled by hand, cost 3 or 4 times as much. The numbers did not lie. Suddenly, driving was no longer just for the wealthy. Rural families, shopkeepers, even farmhands could afford a Model T. Electric vehicles, once a symbol of modernity, started to look like relics of a fading elite. While electrics waited plugged in overnight by the socket, gasoline cars found a new friend on every corner. Oil discoveries in Texas sent gas prices tumbling, and by the 1920s, filling stations were everywhere. Maps from the era show a rapid build-out. By 1930, it was easier to find a gas pump than a place to charge. Companies like Standard Oil lobbied hard, securing tax breaks and zoning advantages that kept charging infrastructure sparse and fragmented. Lead-acid batteries refused to shrink or get cheaper. The economics kept tilting further away from electric cars. Their reputation as clean, quiet city machines faded, replaced by the roar and reach of gasoline. And while the hand crank still haunted drivers, that pain would not last much longer. In the fall of 1973, drivers pulled up to gas stations only to find handwritten signs reading "No fuel today." Lines of idling cars stretched for blocks, tempers flaring as pumps ran dry. The OPEC oil embargo had turned a routine fill-up into an ordeal, leaving Americans stranded and anxious. News anchors counted off the days of shortage. By the time the second shock hit in 1979, rationing and odd-even license plate rules felt like a new normal. Suddenly, the idea of a car that didn't need gasoline gained fresh appeal. Engineers dusted off old blueprints and headlines buzzed with talk of electric prototypes. The city car, a wedge-shaped oddity built in Florida, promised 64 kilometers on a charge, enough for a day's commute, if not a cross-country trip. Big automakers rolled out concept models for the cameras, hinting at a future beyond oil. Yet as gas supply stabilized, the urgency faded. Most electric dreams retreated to the back of the garage, waiting for another crisis to bring them out again. California's zero-emission vehicle rule landed in the mid-1990s like a challenge to the auto industry: build real electric cars or lose access to the world's biggest car market. General Motors answered with the EV1, a sleek, low-slung coupe that could slip down the freeway for up to 140 miles on a single charge. Only 1,117 were ever leased, never sold, mostly to true believers and tech dreamers. For a little while, the future felt possible. Lessees swapped stories about silent commutes and guilt-free acceleration. But behind the scenes, the numbers did not add up. Nickel metal hydride batteries were expensive, and General Motors argued there was not enough demand. When leases expired, General Motors sent tow trucks. In 2003, activists chained themselves to the last EV1s, pleading for a chance to buy them outright. The answer was always no. One by one, the cars disappeared behind locked fences, then into the jaws of the crusher. The heartbreak was real, a glimpse of what could have been, lost to caution and corporate logic. A century ago, the electric starter patent turned the car world upside down. Suddenly, gasoline engines roared to life with a single push, no more broken arms or wrestling with a crank. That one invention, Charles Kettering's 1912 design, erased the last big reason to choose electric. For decades, batteries barely budged while gasoline cars sprinted ahead. But the real twist did not come from a starter or a new engine. It came from a battery breakthrough nobody saw coming. On a graph, the price of storing energy tells the story better than words. In 2010, building a battery big enough for a family car cost more than $1,000 per kilowatt hour. By 2023, that number had crashed to just $130. The curve is not a gentle slope, it is a cliff. Each drop in price meant more range, more power, more people willing to take a chance. The first Tesla Roadster shot from 0 to 60 in 3.7 seconds, faster than most Ferraris, all on laptop batteries wired together in a Lotus shell. The Nissan Leaf made electric practical for the masses, selling over 500,000 cars worldwide. Meanwhile, China built battery factories the size of airport terminals, flooding the world with affordable cells. Charging maps now light up highways across continents, where empty stretches once meant anxiety. If you enjoy discovering how technology keeps reshaping our world, consider subscribing so you do not miss the next evolution story. For the first time in 100 years, the numbers finally lined up. The old starter that doomed early electrics had met its match and lost. The car industry is still feeling the shockwaves. Mechanics who once made a living swapping mufflers and spark plugs now retrain for high voltage systems, while software engineers write code that updates a car overnight. The aftermarket shrinks as electric vehicles need fewer parts, but new businesses appear, apps that manage charging, platforms that let cars sell electricity back to the grid, and services tracking every mile and battery cycle. All this progress comes with its own price. Demand for minerals like lithium and cobalt has soared, pushing new mines into remote corners of the world. Between 2017 and 2023, lithium prices jumped 5-fold, and headlines warn of shortages. Recycling has become a lifeline. Modern plants recover up to 95% of battery materials, but scaling up fast enough is a race against time. In research labs, the next disruption is already taking shape. Companies like QuantumScape and Toyota are running pilot lines for solid-state batteries, promising longer range and 10-minute charging. These pilots are expected to hit the road between 2027 and 2030. Meanwhile, hydrogen fuel cells and autonomous driving wait in the wings, each with the potential to flip the rules again. For all the talk of a final victory, the story is still being written. The road ahead is crowded with new contenders, and every breakthrough brings fresh questions about resources, ethics, and what comes next. Today, electric cars are rewriting the rules of the road and the industries behind them. But every revolution creates space for the next. No technology stays on top forever. Subscribe, watch the next story, and stay curious, because the future of how we move is never truly settled.